networking, what we are discussed about what is network, what is networking, what is internetwork, what is internetworking, what is LAN, CAN, MAN, WAN, different type of networks, about those related information, about the default gateways, NICs, network interface cards, and also we discussed about MAC addresses, how to check MAC addresses, about different type of cables, coaxial cable, twisted pair cables, and also we discussed about fiber optical cables and different devices, hub, switches, routers, modems. Different topologies, bus topology, ring topology, mesh topology, point-to-point topology, point-to-multi-point topologies, okay, extended star topologies, hybrid topologies also we discussed. I showed what is tree topology, but I didn't give any details. Okay, and also we discussed about a OSA layers. Okay, so what is OSA layer? Different 7 layer model it is there. So I think we didn't discuss about protocols and port numbers. So I given some information, I think so. Otherwise, I will tell again. Each and every layer. So we discuss application layer, presentation layer, transport layer, network layer, data link layer, and physical layer. So few are the commands we see ping and trace RT, and that there is a comparison between OSA layer and the TCP IP layer. So OSA layer wise troubleshooting is also there. Next, the last as a thing. Okay, so IP addresses once finished. So we'll try these protocols, port numbers also we'll try. Okay, guys, this is the about your IP addresses. What is an IP address? It is a IP address. IP address is a logical address, whereas MAC address is physical address. It is a logical address. Uniquely identify device in network. I is missing. Okay, so if you are able to tell this entire line, you can tell. Otherwise, leave it. Don't say IP address is a unique address. It is not a unique address. You should not say unique address. Okay, it is not a unique address. It's a uniquely identify a device in the network. Okay, every device, any device, not every device, any device want to communicate in network, either it is local network or internet, need IP address. So important is all communications by IP address only, not with a name, not with a MAC address, not with a name, not with a MAC address. Okay, we cannot communicate with a MAC address. We need an IP address. It is a logical, depends upon the network size, IP address will be defined. Okay, these points, take it. No, not this one, right? This is the one. Okay, here I have given a small picture to know each and every PC having a IP address kind of stuff. So I will try to draw that one here. in a Google Sheets, it's difficult to draw in a Google Docs. Guys, you have a devices, either it is connected wired or a wireless. Devices must have an IP address. So whatever the connection it is, whether it is a wired connection or wireless connection it is. To communicate in the network, what is the main requirement? First of all, they should connect it. How they will connect? You have a device, the device having an NIC. The device having an NIC. What is NIC? Network interface card. Every device must have an NIC. Whether it is a wired device or it can be a wireless device. So for example, you have a computer like a PCA is there or PCB is there. So first they should connect, right? Like this. Okay, so compulsory they should have an IP address. For example, this IP address is 10 dot. You mean IP address? 10 dot is a small one. That's why I'm taking 10 dot to explain. Uniquely identification. See, this is a 1000 is common in both. Only change is this is 11, this is 12. Okay, so small variation in the same network. Also, you can I will put it this on a wireless wide kind of stuff concept. So I'm putting everything in a wide mode only to avoid large confusions. For example, I'm having a PCC. This is also 10.0. Another computer PCD. For example, this is having a like this. This is different one. This PC is in the same network. This PC is in the same network. Okay. These three PCA, PCB, PCC are in a logically same network. Physically, all systems are same network, but logically PCA, PCB, PCC is a same network. How it is? Their network ID is different from this one. Just for a sentence, guys. Later I will explain how it is different, but understand that. Okay. Okay. So like that. For example, if I put a 10, means so their network ID is the same for all the PCs. But there is a problem. This is 11. This is 11. So no two PCs must have no two PCs must have a same IP address. No two PCs means any two or more PCs having a same IP address, then conflict will generate. Conflict will generate. Understand that's why it is uniquely identification. It's not unique. Unique means any IP address, anything, but not same. Not same. Same should not be there, but anything can be there. But this is a logical addressing. So compulsory have to follow logical processing here. So compulsory. I will explain what it is. What I am trying to say is, so I have a machines with different IP address. Compulsory. Without IP address, you cannot communicate, and IP address must be logically in the same network. Okay. Guys, already I think so I told, if in case if I'm not told, but again I'm telling, again, difference between IP address and MAC address. Every device having a MAC address, every NIC having a IP address, every NIC having a MAC address. Okay. Okay, so this IP address is a logical address, whereas MAC address is a physical address. Whereas MAC address is a physical address. Okay. So you already have written. So any device want to communicate in the network, we need an IP address. Without IP address, we cannot communicate. Okay. So without IP address, we cannot communicate. So that we want to take that statements here. We'll say we can change IP address. IP address can changeable. Changeable. So either you either can changeable. You cannot change. Not change. This can be changeable. It cannot be changed. It can be assigned by manually, means the user can do it. Otherwise, it can be assigned automatically also by DHCP server. Already got an idea about a DHCP server last class?
Yes, sir.
Is assigned by manufacturer of NIC. Manufacturer of NIC. There is some more differences are there. So because it's a space problem, otherwise we'll go down. No problem, no problem. Here it is. IP addresses and MAC address, right? In IP address, we have a private and public IP addresses also there. We don't say no private and private or public. Okay, anyway, we don't communicate with that one. Okay, no private, nor a public IP address it is. Okay, so in IP addresses, we have a IPv4 version, which is 32-bit, and IPv6 version is there, which is 128-bit. Whereas MAC address, no versions, okay, and it is a 48-bit, and it is a 48-bit address represented in 12 hexadecimals. Hexadecimal. Okay, so this is the basic points are there. Already I told all communications by IP address only. These are the basic differences, guys. Always IP address and stuff. In IP addresses, in IPv4, one version, another version is IPv6. I can copy paste, but today I want to type sometime. Okay. IPv4 is a 32-bit, IPv6 is 128-bit. Okay. So you take a total size of the IPv4 addresses, number of IPv4 addresses are 2 to the power of 32. number of IPv4 addresses are 2 to the power of 32, which is 4.3 billion IP addresses. Of course, there is a specific number is also there, like this, 2 to the power of 32. You can use the calculator to calculate if you want. You can use the calculator to calculate. So same thing, number of IP addresses here, 2 to the power of, sorry, IPv6 addresses are very large in size, 2 to the power of 128. If you calculate, you will get a very big number, that is 3.4 billion. Okay. Billion IP addresses. We'll get it. Exactly say it is 3.4 into 10 to the power of 38. That is a very big number. Okay. 3 to the power of 38. Okay. So, of course, IPv6 is a next version of IPv4. Okay. And it is a very bigger as compared to IPv4. Example of IPv4 is look like a 192.168.11.1 something like this. It's a decimal. It is a kind of decimal format. Is a decimal numbers here. Here we use a hexadecimal numbers. Okay. Example of IPv6 is look like this one. So 2001. So just for example. Okay. How to tell? Yeah. Easy one is this one. Anything just for our understanding. I'm putting so 4 blocks completed. This is an example for a IPv6. Okay. So IPv6 can be written in different ways, guys. Not only like this guy. Okay. This is a basic information. There is a few more informations also there. Okay. Next, we'll come to back to the IPv4. So IPv4, if you see, it is 4 parts are there. Each part is separated by dot. Okay. So IPv4 divided by 4 parts. Okay. Separated by dot. 4 parts. So 32 by 4, it's a 32 bit divided by 4 means 8 bit is there. Each part is 8 bit size. Each part is 8 bit size. So part size is 32 bit by 4, it is 8 bits. Because of it is 8 bit, because it's 8 bit, it's called as a octet. Called as a octet. So meaning is you have a 4 octets in IP address. So 8-bit means octet means we have a 4 octets are there. Okay. So in IPv6, so we'll come to the IPv6. It is hexadecimal number, guys. First of all, hexa represent 4-bit. One hexa number is equal to 4 bits. One hexa number is equal to 4 bit size. Okay. So 128 by 4. So how many? 32 hexa numbers you are getting. 32 hexa numbers are there. Total 32 hexa numbers are there. So group of 4 hexa. Okay, 4 hexa numbers. If you take 4 hexa numbers, the group of 4 hexa, like this part, 4 hexa numbers. 4 hexa numbers are called a block. Okay. Each block separated by colon. Not semicolon, colon, like this. Separated by colon. So how many blocks are there? Totally in IPv6 we have 8 blocks. We have 8 blocks are there. Eight blocks. What I will do, I'll cut this one. I'll add here. So IPv6 contains 8 blocks. IPv4 contains 4 octets. Okay. So of course IPv6 examples also there. That is also written in this part. Okay. So from here, so about IPv4, I will tell, because IPv6 is also there. So this is only for a small comparison, small points. Of course, some other comparison points also will come. So this is about IPv4, how it is look like. Okay, so guys, I said it contains 4 octets. The first octet called a first octet only. The first one we call it as a first octet. I think it is visibility is smaller. Now it is clear, I think so. First octet. Second one is called as a second octet. Third one we call it as a third octet. So based on the placement, octet is there. I didn't add one point here, guys. That is octet. Octet means 8 bits, right? Octet means 8 bits. The total size is 2 to the power of 8, means it is a 256. So it is a 0 to 255 size. Means each octet is either 0, 1, 2, 3 up to 255 only, not more than 255. Okay. For some people in some textbooks, these octets also they will represent as a W, X, Y, Z wise also, for easy convenience purpose. Some people don't use this XYZ kind of stuff, so that time you may feel the differences. So what I'm trying to say is, you can use this terminology or you can use this terminology. No problem. If you use this one, does not mean you're wrong. If you use this one, does not mean you don't know, kind of stuff. Okay, both are same, only for convenience purpose only. In generally, the mostly as I learn CCNA and CCNP kind of stuff, so I never hear this XYZ terminologies, this textbooks and all. But I read from, I use always first octet, second octet, third octet only. Just in case, like while you are working, while you are in an interview, if you use a W word, XYZ kind of stuff, don't worry, it is representation of octets only. So as I said, one octet size is 0 to 255, means these values can be 0 or 1, 2, 3 up to 255. If it is more than 255, any octet having a more than 255 is invalid. Okay. The first IP address is this one. The first IP address in IPv4 is 0.0.0. Okay. And the last IP address is 255.255.255.255. You know how it is? 0.0.0, 0.0.0.1. It keep goes on. 0.0.2, 0.0.0.3, 4, 5 up to 254. And the last is 255. Once it is completed, guys, 0.0.1.0 will happen. And it continues. 0.0.1.1, 0.0.1.2, 3, 4, like that, 254. Again 0.0.1.255. So it is keep going on. What is the next one? 0.0.2.0. So like that, 0.255.255. What is the next one? 0.1.0.0. It continues. 0.1.0.1, 0.1.0.2. It keep continuous like this. Finally we reach somewhere like finally we reach the last one is this one. So I'm removing this. Okay, this part I'm removing because it's taking more space. If I write, it take another 2-3 pages. Okay, here I've written this side by side in a slide. I've written see 0. Series completed. Next. It keep goes. Very simple numbering only, guys. It is only just a numbering. 99. What is the next one? 100. 199. 99 completed, right? So again it is 200. You reach 99, 999. Then what is the next one? You reach 1,999. It is 200, 000. You reach 4 nines. Then it is 10,000. Okay. Of course, we are keeping numbers, then it is unlimited, but there is a limit here. This is the last IP address in this one. Each octet size is maximum 0 to 255. If you reach 255, then it becomes 0 again. Once you are completed, that's it. So your IP address is completed. I hope you got the understanding.
Yes, sir.
Okay. So this is the full complete range of IP addresses from 0.0.0 to 255.255.255. These IP addresses, otherwise I will write here 0.0.0.1. The next one is 0.0.0.2. keep goes 0.255, then it is 0.0.1.0, 0.1.255, then it is 0.2.0. Like this, it will keep goes. Finally, you reach 255.255.255. This is entire range of a 4.3 billion IP addresses. 4.3 billion IP addresses. Okay, the entire IP addresses divided into 5 classes. You know why? Why we divide IP addresses into 5 classes? There is one thing is there. So this entire IP addresses are 4.3 only. If you start giving one by one IP address, if you start giving one by one IP address to each and every student, each and every afternoon class is very difficult. Okay, so each and every device you start giving an IP addresses. Think how many devices we are using. Even for a one person nowadays, how many IP addresses we are using? I am using a laptop, mobile phone, desktop. Okay, so how many IP addresses? We keep using so many IP addresses for a person itself. If you take an organizations, for example, Savant is having lot of computers, right? So like that, in the world there is a lot of IP addresses requirement is there. So that's what they divide into several parts, and we can assign an IP address according to your class. You can choose in a class. Total IP address is divided into 5 classes based on your requirement, your service requirement, based on your number of systems in your local machine, number of systems. Based on the number of systems, you can choose. Based on number of systems, you can choose which class is suitable. Okay, so that is a one reason. Of course, IPv6 having a one network, multiple, so many billion IP addresses we are getting in IPv6. So in one single IPv6 network, so we are able to connect lot of devices. Even okay, so that is one point, guys. Second point is why we divide IP addresses into classes, and there is a subnet mask management is there for controlling number of IP address utilization and divide them into private and public. So you are in a private, so you can use private IP addresses. When you are communicating outside of your private network, means through internet, you need a public IP. Okay, so we have a number of servers and all, they are utilizing public communication only, but internally we are using private. In a private, there is no particular rules, like you have to pay for a private IP address, no need to pay anything, but you need a public IP, you have to pay. Okay, so it is entirely managed by ICANN. These IP addresses and all assignment is in the hand of IANA and ICANN only. Yeah, so don't worry, I think you didn't get any point. So entire IP addresses, IPv4 addresses divided into 5 classes. Okay, to identify class, okay, check the first octet, or you can say the W part of IP address, IPv4 address. Okay, to identify which class of IP address, to identify the class, so check the first octet. Okay, the division is occurs in the first octet only. So we'll directly go class A and class B, class C, class D, class E. So totally 5 classes are there. There is a binary priorities also there. So I will type, guys. Okay, if you cannot remember the binary thing, no problem. So anyway, the first octet is start with the zeros. Okay, IP address first octet. For example, you take this one. This is the first octet. 0 is the first octet. So this is the first IP address. Starting is anyway 0. Okay. So the first octet starts with a 0. Is there. And in a class A, so how they will divide? They keep a 0 as a MSB is same. First bit is same. Remaining bit becomes inverted, means become ones. Okay, so it is a 0 to 127. So class A range is 0 to 127, but in some places it shows 1 to 126 or a 0 to 126 or 1 to 127. Why it is there also now only I will tell, guys. 0.0.0 is a reserved IP. Reserved IP address, also called as a unknown IP address, unknown host kind of stuff. This is also unknown, used in a specific services. Okay. Anyway, the entire 0 series you are not using or cannot assign to any NICs. Can't assign to any device. Next one is very important, guys. Listen carefully. 127.0.0.1 is a reserved IP address for a local host or loopback IP address. What is this local host and loopback IP address? Simply it is, there is a diagram. Okay, so look at here, somewhere I have written this diagram. Okay, I will tell directly, guys. I have a laptop. This is my system. This is my system. Okay, in my system is configured with an IP address. Okay, I have connected to network and I have an IP address. Okay, so what is my IP address? Yeah, this is my IP address. Where it is? This is my IP address. Okay, so if you are in my network, you want to communicate to my PC. So how you communicate? Like for example, you want to ping to my 172 dot something dot 59 is there now. So if you ping with this IP address from other PC, what happen? Ping request go to your PC, then you will give reply according to it. Okay. For example, I have an application, some web-based application is running here. You want to access that application from here. So what to do? Web-based, right? So it is HTTP protocol. So put the my IP address. Then request come to my PC and you will get a reply from me. Right? Understand, guys? IP address.
Yes, sir.
Because of these two PCs are connected in the network configured with an IP address, they will communicate with an IP address of mutual source destination wise. In case from my PC I want to access this application, or from my PC I want to ping to my PC. Okay, so you don't need to know what is your IP address, simply can use this IP address. Okay, for example, you want to talk to me, then you have to call me with a name, right? So, Sir Latif, sir, what is this? Okay, so we two-way communication, two people are communicating each other by addressing them, but it is a self communication, myself. Okay, I'm telling myself. So I need a name, so then other person can able to recognize me or communicate it to me with my name. But if I want to communicate myself, I don't need a name, right? I said myself, right? So that is a local host. For example, this is PCA, this is PCB. Both PCs are having names, but local host is self-naming. For example, from A, I ping to 127.0.0.1. The ping request go to A only. From PCB, I'm pinging to 127.0.0.1. Ping request go to BPC only, not A. Because of every PC as itself name is localhost and IP address is 127.0.0.1. So it is a reserved IP address for localhost and loopback. What is the use? Generally it is self-testing purpose. Self-testing. How self-testing? Ping to 127.0.0.1. You can use it. Access the local services. To access local services like web services and database services.
Sir, sir, what is the meaning by loopback means?
Loopback. Back.
Yes.
Yeah. Loopback also like a self-test. Means loopback with loopback IP addresses you cannot communicate it to anyone. It is a self purpose only. Okay, it is self itself.
Okay, sir.
Self assigning, self.
Yes, yes.
Your remote machine and our machine means I have a laptop. I want to communicate it to my remote PC. How to communicate with the remote PC IP address. But here my remote server and my PC both are same. Both are same. Okay. In that cases, I can use the loopback ID or localhost IDs. In IPv6, okay, loopback or a localhost ID. This is an IP address now. So ID is ::1 ::1. Okay. In IPv6, for this 0000, it is just : only. : in IPv6 is this one. I will show you this, guys. So, sorry. Linux habit typing clear command. CLS in Windows command. Okay, I am pinging to 4. 4 means ping-4 means ping with the IPv4. IPv4 ping is ping space -4 localhost. What is my localhost IP address? 127.0.0.1 in IPv4. In IPv6, same localhost in a IPv6 is ::1. This is a self-test. Is your TCP IP is working or not? Okay, TCP IP service is working or not? To test it, we can use that ping command. Okay. You may get it out like, can you ping with the ::1? Yes. Okay. I'm pinging to myself with IPv6 address. Okay, guys. So these two IP addresses we cannot assign specified or specific services. We cannot assign to any NICs. Exactly say this part. We cannot assign to any NIC or adapter. What accept? Okay, we can't assign. We can't assign 0 series. We can't assign 127 series also, including 127 series. Not using kind of stuff. Can't assign to anyone. So that's why, that is the reason in certain test works they don't give 0 to 127, but by default this is the total range, but usage range is 1 to 126. What is the next number of this one? Is very simple, 1000000. It's just a numbering system only. So class B, class A, first bit is same, remaining is changed. In class B, first two are same, remaining become ones. $191. In a class C, so what is the next number? 11. This is the number. Okay. So in a class C, first three are reserved. 110 is reserved. Remaining become ones. It is a 192 to 223. Okay, the value it is. Binary value I am writing, binary to decimal value I am writing here. This value I am writing here. What is the next one? 1110. Like this. This is the next number of that one. And here 1, 2, 3, 4. Totally the first 4 is reserved. Remaining become ones. 224 to 239. 240. Sorry. 111. 4 zeros. Means 4 ones, 4 zeros. Here last one, right? All are ones. All are ones. 8 ones means 255. So 242, 255. Guys, OSA layer, again 7 layers are there. TCP 4 layers are there. Now it is IP addresses, 5 classes are there. How to remember? I don't mind whether you by heart or you practice, you find any logics behind it. Try any which ways, you must remember this information. Next also there some information will come up. Okay guys, so this is our IP addresses and their classes it is. Second one is recognition of IP addresses. Recognize IP address based on what is the classes. Okay, based on first octet, you have to tell what is their classes. I'm giving same example, no problem, otherwise I will change it also. Okay. Yeah, I will change something. Okay, so 90.9.200.1. Which class it is? Anyone guess?
So class A.
Class A, very good. See the first octet only. Don't mind about the remaining octets. Only first octet. 90. 90 is in the range of in this one. Okay, it is a class A. Second one.
Class B.
So class B.
Class B. 151. 151 is in between this range. This one.
Class C.
Class C. 197. Only look at 197 where it is suitable. Class C. 224.
Class D.
Class D. 240.
Class E.
E.
Class E. Why? What happened to this? I removed also. So class C. Then what is this?
So class B.
Class B. So it is only look at first octet only. And all octets must be, all octets means first, second, third, fourth must be less than 255. To recognize the class, always look at the first octet and check the ranges, and you can recognize which class it is. 170, 170 only. So what is it? Class B. Guys, in this one, the class E we don't use it. It is reserved. And some people say it is R&D purpose. It is a reserved. We don't use it. It is a R&D. This is a multicast. Multicasting purpose. Used by some protocols. Used by some different protocols. Cannot assign. Not assigned to NIC. It has become a very big lengthy one. It is a multicast used by certain protocols only. We cannot into NIC. But these three protocols are a unique cast addresses. These three protocols are a unique cast. We are using class A, class B, class C because these three are a unique cast addresses. But how to put this arrow kind of stuff? Drawing is not allowed here. Okay. Class A, B, C are a unique cast addresses. Okay. So these are the classes, guys. Okay. So there is a lot of things are there.
Sir.
Yeah, tell me.
So what is the problem with multicasting? Like why we can't assign the IP addresses of class D range?
Yeah, very good. What is unicast? First of all, I have a device. are there. Okay. For example, I send a packet from A to B. Okay. So I use my destination IP address is B's IP address here. So packet is goes to B. I want to send A to C. Then what is my destination IP address? C's IP address. So this is called a unicast. Okay. Then what is a multicast? If all these systems should work in a means the selective systems must have a one single IP. For example, I send a packet to a particular IP address. For example, 224.0.0.5. Okay, so a packet is sent to this as a destination IP. So this IP can be for this PC, this PC, this PC. So to which species means the destination is not one, it's multiple. But in a really in a basic communication we don't use it, but we use it those things in the different protocol wise. For example, you have a routers. Okay, multiple routers are there. So these routers are connected, and they are also having a unique IP addresses only, means unicast IP addresses. But when they want to exchange this information through EIGRP, OSPF, or RIP protocols, if you implement those protocols here, they will exchange this data to one router to another router using multicast addressing, because of it is like a group messaging. So individual NICs do not have, we cannot configure multicast address because multicast address used by a different type of protocols. For example, I have a 10 computers and there is a server called a WDS server, Windows Deployment Server. WDS, Windows Deployment Server. What is this WDS will do? It will install the operating system into the remote PCs through network. Through network, we can install operating system also. We can deploy OS through network. Each individual one is having a unicast address. But this OS deployment use a protocol called bootp. This utilizes automatically a multicast address. We don't assign, it will use certain multicast address to transfer the bootable data. Okay, but each one is recognized in a unicast way, but they will do this work with the product. So multicast addressing is also we cannot assign to NICs. If you have a doubt, I will show you that one. We'll try. This is a NIC already configured with an IP address, that is 10.1.11, which is unicast address class A, right? So I'm assigning 127 first doubt. Yeah, it is showing you cannot assign 127. You can do 1 to 223. You can do 1 to 223. What is 223? End address of unicast addressing class C 192 to 223, not even 224. I put a 224. Again, 224 is not valid entry. Please specify 1 to 223. So this multicast addressing is used by whom? Certain protocols only uses certain services, multicasting wise services, then it will.
Yes, sir. Okay, sir. Thank you.
Next one is there, guys. One is IP addresses and their ranges. Okay, sorry, IP addresses, classes we discussed. Next one is subnet mask and network and host portions are there. I will tell very basic level only, guys. So why should we worry more? Slow and steady more time, then we can try. Look at here, guys. This is a actually this is I want to put like this, but it is not existing according to us. This is a limit. Limit is there, so do not worry about a limit. Guys, this is the class A. This is class A, class A, class B, class C are unicast addresses in the networking. While unicast communication we use either class A, class B, class C. Okay, each class okay, each class separates. Okay, each class is defined as a network and host portion. I will tell what is network. Host portion means. So just for example, you are in an apartment floor. The floor numbers are like this. Not floor, up door numbers are like this. What is this meaning? Third floor, example, third floor, and door number is 4, door number is 5, door number is 9, door number is 10. But we can recognize all are in a third floor only. All are in a third floor only. The 4, 5, 9, 10 are a door numbers. So this is how we are separating floor and door numbers. Pin numbers, roll numbers. For example, your batch 10, right? Your batch 10. I'm giving a roll numbers to you 0, 1. Okay. 2. Like this. So what you will understand? I'll take some random numbers. So it is 10, 29 people also there, right? So I given a 10, 10, 19, so 10, 22, 10, 34, 10, 44. Example. What is this entire meaning? What is 10 represent?
So batch 10.
Batch 10. 1, 2, 3, 4, 19, 10, 22, 34 represent?
Sir, what after 99 1099? Then again 100.
Column will occur. And column will occur, or otherwise we have to adjust the column like this. So you got a 99 members are came. Then if I want to put it 10, 100. So if I want to keep 4-digit manner, it is impossible. Then you have to go to 5 zeros afterwards. Otherwise, what to do? Expecting more than 99. Expecting more than 99. Any numbering you are giving, you are expecting more than 99. Okay. Maybe your maybe 150 members may join. Maybe 200 may be join, but not more than 999. Then I will start with a like this. Then I will always 10 as the same, but this will be keep changing till 99. A very good question actually. It is not much silly part, but see it is. You can assign, right? So what is common between these two things? 10. What is keep changing? Last 3 digits. Okay. Very good. Just for our understanding, so I am giving, if in case like this happen, so that is the limit. But 10 is a common for up to 99. But you have to think like this is another example. So this is another example to tell like this arrangement. Of course, we have a IP address has a certain limits. We cannot pre-configure, but understanding the concept is important. Pin numbers, roll numbers, how we will divide into the batch wise or a section wise or a group wise, like ECE branch, EEE branch, mechanical branch, okay, like kind of stuff. Okay, same way, the IP address is divided into network and host person. Example I written, but I will start from here. IP address is divided into 5 classes, and IP address, if you take any IP address, divided into network portion and host portion. Portion, not partition. PORT. Portion. Auto correction confusion. Network and host portion. IP address is divided into network and host portions. The rules here, two or more devices better word is devices can communicate if their network portion is same. Their network portion is same. Of course, host can be different. No problem in it. Okay, host portion must be same. So how to recognize host and network portion, you can see from this some examples I've written. Okay, like this. This is a class A IP address. Class A network portion is first portion is network portion, remaining is host portion. So this is the class A IP address. The first portion is network portion and remaining is host portion. Class B, first two portions are network portions, Okay, these first two portions are network portions, and remaining two portions are host portions. Class C, first three portions are network portions, and Class C, first three portions are network portions, remaining is host portion. So like that, the IP address contains network and host portions. If it is a Class A, the first portion is network portion. First portion is network portion. Remaining three are a host portions. Okay. So Class B, first two octets are a network portion. Next two octets are a host part or portions. Class C, first three are a network portion. Last one is a host portion. So it depends upon this table we can able to understand directly. Why we are dividing the classes? First of all, why we divided IP address into classes, and why this usefulness? So can you see here it is? This is number of host portions are one only. Number of host portion is one, so it means 8 zeros. Okay, 8 zeros. Okay, here note down this thing kind of. So it means they note once represent network, zeros represent host. Now I will tell that one in binary. In binary, ones represent network, zeros represent host part. So based on that, we are getting this one. Okay. So if network is there means ones are there in binary. H is there means zeros are there in the binary. Okay. This is H. One complete octet is H. One octet means 8 bits. So number of zeros are 8. 2 to the power of 8 is 256. And there is a minus 2. Why a minus 2 I will tell. And the total is 254. Why minus 2 I will tell. Okay. So a network example, one network, one complete network. So how it is there? One complete network means totally one logical network means. Look at here. So I took a one IP address 192.168.0.0. This is our network starting, or I will give 10.0 just for our understanding. So this one is start of network. It is a network ID. This is called a network ID. We cannot assign network IDs to recognize it is not showing any error. To recognize network, what kind of network it is, network ID, and we cannot assign. Cannot assign. We cannot assign to anyone. Okay, we cannot assign to anyone. We cannot assign to NIC. Okay. Next, 168.10.1. It is called a first valid IP address. Host ID. First valid host ID. We can assign to host means NIC from here. And next one is 192.168.10.2. It keep goes 192.168.10.254. 254 in this one, it is a last valid host ID. Okay, host ID. We can assign up to here 168.10.255 is called a my left hand is getting a lot of pain, unable to type also. Okay, so it is a broadcast ID. It is a broadcast ID. Next one is, this is also cannot assign to host, means there NIC. To machine, host means computer, device, anything. So this is one. So what is the next IP address? Next one. This one only, right? Okay. But
Yes,
if you
sir.
see from here to here, I said class C, first three are a network portion. If you see from here to here, all are first three portions are same. Only last portion is keep changing. Now it is the third portion is having changes there. It means it is other network. Okay, it is a different network. Then okay, then our network. So other network it is, other network ID it is. It's not our network. It is not our network. This is our network. This is not our network. So one network means complete network means this is completely network portion must be same and a host portion start with a 0 to 255. Final number should become. Of course, I can show for a class B also, but it is very big one. If you want, I will show, no problem. Okay. But you can see y 254, y minus 2. See it is in this entire list 0 to 255 means 256. First one we are not using, last one we are not assigning. First one we are not assigning to anyone, last one we are not assigning to anyone. That's a minus 2, it is 254. Okay. So in class C guys, we can one single class C IP address, in one single class C IP address, okay, we can connect 254 devices. Okay, in one single class C network, 254 devices we can connect. Even I got 11, right? 11. In this one, 11 also 254. 11.1, 11.2, 11.3, 11.254, 11.255. So 0 we don't use it, 255 we don't use it. So 1 to 254, totally 254 devices we can connect in this network. But this is a different network from here. Both are class C, but it is a different network. Okay. Class B. Class B, network portion. First two are network portion, remaining is host portions. Two host portions are there. Two host portions are there. Each portion is 8 bits. 2 to the power of 8. 2 to the power of 8. Sorry, 8 plus 8, totally 16 zeros. Host portions are 2. Each portion is 8 bit. 2 portions 16. 2 to the power of 16 is minus 2. So 65,536 minus 2, 65,534 devices you can connect in a class B network. If you want, I will take a one class B network. So 16.0.0. So what is this? It is a my network ID. We can't use that one. So IP address start from here. This is the first valid host. and it keep goes on 172.16.0.2. It keep goes 172.16.0.255, 172.16 1.0, okay, and 172.16 1.1, 172.16 1.255. Like this, it will keep goes 172.16 255 254 172.16 255 255. Now this is a broadcast ID. This is the last valid host ID. It's a 5 o'clock. Okay, so if you want to write all 65,534, totally 36 minus 2, right? So minus 2, 1, the last one is also minus. So this complete range from here to here is 65,534. So meaning is this network is changed. So it is the other network from here, different from here. See, different network. So this is the range. So if you are having a more than 254 pieces, like a more than 300 pieces are there, okay, or 500 pieces are there, or 1,000 pieces are there, then what class it is better? Class B. Up to 254, class C. More than 254, class B. Up to 65,534 devices. If you cross that device limit in a one single logical network, you have a more than 65,000 devices are there, then go to class A. In a class A, first portion is network portion, remaining is host portions only. So 3 host portions, each one is 8, totally 24. It is a 16 million IP addresses we are getting. 16 million IP addresses we are getting. That is the limit of one single class A network. Okay. So in this one, small part is there. That is a default subnet mask. Default subnet mask. First of all, what is subnet mask? Here it is already neatly written. So yeah, recognition first of all, then we'll see remaining. Okay. I'll give you a break, don't worry. Sometimes we cannot know how much time we are here. Devices must be same network to communicate with each other. Device network portion must be same, whereas their network ID must be same. Means enter these IP addresses having same network ID. Enter all these IP addresses having same network ID. Means if you want to communicate with their network ID same, they will communicate each other. Yeah, tell me. Okay.
Sir, actually, there was some problem with mic. You were not audible earlier, but it's now okay.
Okay. So then good. Yeah, we didn't miss much. Okay. So device must be in a same network to communicate each other. Devices must be in the same network to communicate each other. Okay. So check their network identification. Okay, and their network IDs. Okay, then only they will communicate each other. You have a two different networks, they're logically different, physically, logically, two different networks are there. You can use a router to make a communicating between them. In generally, like you have two separate networks are there, two different logical networks are there. How to make a communicate between them using a router. Why router? It is a inter-networking device which may communicate between two or more different networks. Guys, see, I have one PC. I have another PC. Is IP address are assigned like this. And these two PCs can communicate each other. It is a class B. First two portions are network portions. Look at the first portion, same. Second portion, same. Third and fourth are host portions. And that too, some difference is there, no problem. Okay, not required to complete difference. At least one of the difference is there, no problem. Okay, so this is good. Okay, so network portion is same for both 1 and 2, they will communicate each other. I have a PC3. PC3, first portion is same, second portion is same, and third portion is also same. From here, it is different. But the third and fourth, both are class B, that is host ID, first two are network. So of course, PC1, PC2, PC3 will communicate each other. Then we receive PC4. First portion is same as other PCs, but second portion is 70, means different network. Means PC1, PC2, PC3 will communicate. PC4 cannot communicate with the first three PCs because it is a network portion is different. Okay, so like that we can recognize different network kind of stuff. So it is APC, BPC, CPC. It is a class A. The first portion is network portion and remaining are a host portion. So what to check? Only first portion. So first portion same for A to B? Yes. C, first portion is different. So AB can communicate, C cannot. So last time some people ask me question, sir, it is a different network, then can we use a router? Guys, you have a 10 computers. By accidentally, for one or two PCs, you given a wrong IP address. Means different network IP address you are given. It is a mistake, right? So there is a three PCs, A, B, C, three PCs are there. A, B, both are you given correctly. For C, you given wrongly. What to do? To correct that wrong, you cannot use router there because router is a costly equipment, not 5 rupees, 10 rupees chocolate it is. So earlier it is 20 to 30,000 basic router. Now it is maximum 50 to 60,000 rupees for basic router. Okay. We don't use router for every time, but router is inter-networking device. In different network wise we will use it. That's the point. Not every time you do mistake. What to do if you do a mistake? What to do? Check it. Check both are in the same network or not. If you do mistake there, correct it. Make it is 100 as a 101. Okay, that is enough, right? Same goes here. This is the class C. A, B are able to communicate each other because of first portion, second portion, third portion, three portions are same. But CPC, third portion is different from AB. DPC, second portion is different from AB. EPC, first portion is different from AB. So AB can communicate each other. CDE cannot communicate it to A and B, not even each other also because of the network configurations. Here I have written some people will do certain mistakes by their typing. So 170 to 168 instead of 16. Okay, because of 190 to 168 is there. 190 to 168 is there. So mind will small trick it sometimes. This is 192, this is 172. So when they type 172, immediately they put a 168 like this. Instead of 16, they put a 68. In internal your local network, nothing, no problem. But this is the private IP, this is public IP. When you are configuring, you have to compulsory, you have it for 2 devices are there, 3 devices are there. So you are doing some practice. So you are assigning an IP address, compulsory check their IP address, are you enter correctly or not. The small mistake with the IP address entrance, so it has become big problem, big headaches. Even myself, I suffered with that one. Okay, of course. And of course, yesterday we discussed in a DHCP manually, there is a possibility of entering wrong IP. Some people for 192, they remember 190, they will put a 190 instead of 192. Okay, so one device is 192, another device is 190, and another device is 172, 168. Okay, so that is the problem some people face. Compulsory check in the troubleshooting, both IP addresses are same network or not. I have to give break, guys, to you, but I'm not giving break. If I keep like this, you will die. Now what you do, take a break, guys, take a 10-15 minutes of break, and we'll see this subnet mask, private IP addresses, NAT kind of stuff. Then your IP address part is completed. Tomorrow, I'm going to start with the PC hardware basics. Okay, and anything you miss out also will cover. Outlook, those kind of stuff is there. So now take a break.